Eldrin and Pantoja, grade 12 Genesis, representing Megatron.
Hi, my name is Angelica Pedraza. I'm from grade 12 Genesis. And I'm from Megatron. Hi!
Hi! I'm Brianna Bascuguin, grade 12 Genesis from Megatron! Hi!
In these activities, we explored how the serial monitor helps the Arduino communicate with the computer. In the first activity, the Arduino sends a message saying, "Hello student," every second, showing how to print text on a serial monitor. In activity 2, it reads temperature data from the sensor and displays the temperature in degrees Celsius. Activity 3 detects when the button is pressed and shows the message on the screen. In Activity 4, we can control the LED by typing 1 to turn it on and typing 0 to turn it off through the serial monitor. Finally, Activity 5 measures the brightness from the light sensor and displays changing light levels on the monitor. Altogether, these exercises show how the serial monitor lets us send, receive, and understand data between Arduino and our computer.
Hello, now we will talk about the ultrasonic sensor. Ultrasonic sensors are devices that can measure distances by using ultrasonic sound waves. The pin VCC of the sensor will connect to the 5V of the Arduino Uno, GND pin to GND, trig to pin 9, and echo to pin 10. For our first activity, we only measure the distance and display it in the serial monitor. Whenever the sensor is in front of an object, it will automatically measure the distance and sends it to the Arduino Uno. For the second activity, same as the first activity, but we had only an LCD display the distance measured. On our third activity, we set up an LED so that it would light up at a set distance. The next one is our fourth and last activity, which we made a parking assistance system so that one of the three LED will light up depending on how close it is to the ultrasonic sensor. Blue meaning the parking is safe and away from danger, yellow showing that the vehicle is midway noting something, and finally the red LED indicating that the vehicle is very close of hitting an object or a wall. We have here the IR proximity sensor, which detects the presence of an object without physical contact by using infrared light. The pin VCC of the sensor will be connected to the 5V of the Arduino Uno, GND pin to GND, and then out to pin 2. For our first activity, we tested the sensor by placing it in a white and black surface. The sensor then would detect the color of the surface and show a text into the serial monitor, displaying the color of the surface detected. For our second activity, we added an LED and a buzzer so that it lights up and makes an alarm when the sensor detects an object. For our third and last activity, we used an LCD to show the amount of objects that the sensor had detected. Every object that the sensor detects, the counter displayed on the LCD increases by 1.
In these activities, we discovered how the Arduino Uno can control a DC motor using different input components. The Arduino turns on the DC motor when the button is pressed, and turns it off when it's released. The MOSFET acts as a switch that powers the motor. Pin 2 reads the button state, and pin 9 controls the motor's power. This setup controls a DC motor speed with a potentiometer. The Arduino reads the knob's position and changes the motor speed. Turning the knob one way makes the motor spin faster, and the other way makes it slower. Overall, these activities show how the Arduino can use simple input devices to control motor functions, helping us to understand the basics of input and output control electronic systems.
Use a DC motor with an H-bridge motor driver with the Arduino Uno. The H-bridge is useful when using two DC motors since it controls the flow of the current to an electric component and avoids the breakage of the motors. In Activity 1, the code is set so that the DC motor will power on and off and run for a second, then power off for 1 second, and the process repeats. It will run for 1 second, then power off in the next second. This circuit is the same circuit used for the first three activities. In Activity 2, the DC motor is coded to gradually increase and decrease in speed. This is done via pulse width modulation, wherein the power signal is manipulated by turning the signal on and off in the cycle at a set interval. The end result is the DC motor speeding up and slowing down. In Activity 3, the DC motor is set to spin in both directions, forward and reverse, by controlling the logic signals sent. By manipulating the logic signals, the DC motor will spin in both directions. In Activity 4, there were two buttons added to the circuit, one button for the motor to spin forward when pressed and the other coded for the motor to spin in reverse when pressed. In Activity 5, the first two buttons remain and the potentiometer was added to the circuit. The function of the potentiometer is to control the speed of the motor. In these activities, we learn how important it is for a motor driver to be present when using a motor. One, to avoid overloading and breaking the motor, and the second is to help us manipulate the actions of the motor easily. From Robotics 1, 2, and 3, I have learned a lot about circuits, electronics, electricity, and electric components. They've really helped me learn more about how circuits work and how these things connect to each other. And for this thing to work a certain way, this has to have this certain module so that it doesn't get overloaded. This does really help me in engineering and in STEM courses because majority of STEM courses really do include the making of your own device, or at least conceptualizing your own device. And this has inspired me to create or draft more projects that can benefit others in society. The other components that I would like to try more are the ones that have sound included. I'm very interested in how we can code the Arduino to receive sound and also output sounds. I'm very interested in those kinds of electric components.
We have learned how different electrical component works, their uses, their benefits, and their applications in the real world. We tested electrical components including the serial monitor for data viewing, IR proximity sensor for detecting the presence of an object, ultrasonic sensor with distance measuring, and the DC motor for rotational motion. We also added different components like the LED, LCD, buzzer, button, and many more to see how each component works with the main component used. Our robotics journey was fun, educational, and sometimes chaotic. These courses changed my view of technology due to these components improving our quality of life and experiencing its unique features. This motivated not only me but everyone to test or maybe improve existing devices. I would like to try different microcontrollers, especially the ESP32, as I would see debates on what is the best microcontroller, either the Arduino Uno or the ESP32.
Through all these activities, I learned how to connect and program different sensors with the Arduino, like temperature, distance, and motion sensors. I understood how each component works together to collect and display data. These lessons improved my coding, wiring, and problem-solving skills, and showed me how Arduino can be used for real-life applications.